As we all know, AI has been around for decades. We all have been using it in different capacities without realizing it. But recent breakthroughs, especially in the large language models, it is reshaping its role in the enterprise and consumer world. While much of the attention is on consumer AI, the fact is that real transformation is happening in the enterprise space where businesses are leveraging AI to drive innovation, efficiency, and competitive advantage. But running LLMs can be expensive and complicated. That's where companies like Akamai, who have democratized cloud computing, come to play. Today we have with us Bobby Blumofe, EVP and CTO at Akamai, to deep dive into this topic. Bobby, it's great to have you on the show.
Thanks, Swapnil, and thanks for having me.
It's my pleasure. I mean, if you look at AI has been around for decades, and while it has been widely used, recent innovations, especially from OpenAI, Meta, Google, Microsoft, and Deepseek, have kind of reignited interest in this space. While most media focuses on consumer AI, it is the enterprise space where the most significant AI advancements are taking place. I would love to hear your perspective. How do you view AI's evolution?
Sure. Yeah. Actually, from the point of view of enterprise, and certainly specifically what I'm seeing here at Akamai, and I've been at Akamai now for over 25 years, so I have a pretty good perspective on the history there. I actually break it down into three distinct epochs. In the first epoch, really AI was, I would say, largely irrelevant. Most of our customers didn't do anything meaningful with AI. We didn't do anything meaningful with AI. And that changed. I think sort of the dawn of AI life occurred around 2014, 2015 with the advent of deep learning. And suddenly with deep learning, you had this powerful tool to do interesting pattern recognition tasks. And for us, where we were doing a lot of work in cybersecurity, it turned out to be the ideal tool for detecting patterns in traffic, identifying what's normal, what's abnormal, what's benign, what's malicious, what's human, what's bot, and so on. So deep learning became a big part of our repertoire starting then, about 2014, 2015. So that was sort of the dawn of life. And then about 2 years ago, we kind of hit the Cambrian explosion, where suddenly you had generative AI, large language models, and that just created, as I said, this Cambrian explosion where now you've suddenly got new capabilities that can be applied in a much broader set of circumstances. So now you're in a situation where almost every product in our portfolio can use AI and does use AI to improve the customer experience or improve the performance of the product. But also internally, of course, improving the employee experience, making employees more productive, able to do their jobs better. So I think of AI in terms of those three epochs.
Beyond all the hype that we see today, how are enterprises looking at the new generation of AI, if we can use the term legacy AI for the previous generation? And I don't mean by GenAI. This new generation of AI is much more advanced and interactive than the previous generation. So when we look at enterprises, kind of getting interested in AI, is it the same as we need to get on LLM bandwagon because everybody else is doing it, or they see it solving real business problems for them, especially with the advancement in terms of cost and access to these technologies? The question is about hype versus reality.
Yeah, well, there's a lot there. Let's start with Deepseek, because I think Deepseek really, hit the headlines just a little while ago, and I think it alerted a lot of people to the fact that the state of the art in LLM optimization, efficiency, scalability, cost across both training and inference has moved quite a bit over the last 2 years. And to be honest, I was a little surprised at the headlines because I was surprised that is a surprise to anybody. The fact that we've advanced over the last 2 years really shouldn't have surprised people. One of the headlines that I saw many times is that Deepseek was able to train a GPT-4 level model at 1/20th of the cost. That sounds interesting, but remember GPT-4 was trained 2 years ago. And the notion that in 2 years, the cost to do the same thing, roughly the same thing, has come down by a factor of 20, that shouldn't be all that surprising because, of course, there's been so much attention. Now, I don't want to take anything away from what Deepseek accomplished. I read their technical reports in great detail. They're detailed. They're very interesting. They've disclosed a lot. And in many ways, it's a tour de force of optimization. From optimizing the model itself, they optimize the attention heads, they optimize the feed forward layers, they've optimized on the way they do quantization, they optimize the training pipeline. It's a tour de force of engineering optimization. But I would say that all of their optimizations, while they're extremely well executed and in some case even advancing the state of the art, they are all in the category of steps along the state of the art. Steps that are notable, but again, incremental steps. So it really shouldn't have taken people by surprise, but it seems to. But the big lesson that I think everybody should be aware of is that now you can do a lot more with a lot less. Again, not all that surprising. So the big models can now be run much more efficiently. They can be built more efficiently and trained more efficiently, and they can do inference more efficiently. And the small models are becoming much more capable. And that makes the opportunity much greater because if you think about the enterprise opportunity, scale matters. And if scale matters, so does cost. You can't deploy these things at a loss. You need to deploy these things with a real ROI, and that means you have to find a way to deploy at scale with high performance, reliability, and low cost. So I think what we saw from these headlines was an important reinforcement of a fact that many of us have known for a while, which is that you can do a lot more with a lot less today.
I mean, so true. And we all stand on the shoulders of giants, whether we look at the Linux kernel, whether we look at the Kubernetes. So while OpenAI and others have done a lot of legwork in this space, Deepseek, with its reinforcement learning, has further advanced the reasoning capabilities of LLMs. What impact do you see of Deepseek on the market?
Yeah, again, I would put it in the category of evolution, but I would actually put it in a larger category of LLM advances more broadly. One of the really notable things about LLM, to their great credit, is just how malleable they are and the extent to which they allow for optimizations to improve their performance in various domains. You know, you've probably read about things like prompt engineering, that you can improve the performance if you prompt in the right way. You might have heard of chain of thought prompting. And again, that shows that you can improve the performance in certain domains by prompting in a certain way to get the model to elicit more of a chain of thought. Reinforcement learning is in that category, that through reinforcement learning, you can get the LLM to produce better responses in certain domains, especially in domains that are somewhat closed-ended, where you can automatically calculate a reward, right? Because in the case of reinforcement learning, a key component of reinforcement learning is a reward function. How do you figure out what the reward is? Well, in the case of certain closed-end types of problems, like mathematical problem solving, puzzle solving, coding, you can fairly automatically determine what's a good answer and what's a bad answer. So reinforcement learning works great there. You might have heard of things like inference voting, inference search, tree of thought. The list goes on, and there's new ones that appear every week. And each of these examples is a different way to sort of nudge the LLM in a direction that improves its performance. And it's somewhat remarkable that LLMs are, that they admit all of these different ways where they can be improved so that you get better answers in certain domains. And again, I really think that that's remarkable, and it's making LLMs, I think, more broadly applicable and better able to solve relevant problems. I'd be remiss, though, if I didn't also point out that while these things are these techniques, reinforcement learning and the other ones that I mentioned, are pushing the envelope substantially. What they're not doing is solving the inherent limitations of what an LLM actually is. And I think that's an important thing to remember. As remarkable as they are and as much as they can do, they can't necessarily do everything that they've been hyped to be able to do. Because ultimately, an LLM isn't really an agentic technology. It's really more of a sort of reformulator. It reformulates, represents in different ways this stuff that it's been trained on. And while that's valuable for a lot of things, it doesn't solve everything. The LLM is not the answer to all things AI. And as wonderful as these techniques are, like reinforcement learning, inference search, all these other things that we see in these so-called reasoning models, it's not an actual solution to these limitations. And as much as we push the envelope on these things, and it's great, it's not going to actually, for certain domains, for certain types of problems, get you to the number of nines of reliability that you're going to need to produce a truly autonomous and reliable agent.
Since we are talking about Deepseek, and they made headlines by proving that LLM training and optimization have significantly evolved. They showed that training a model at GPT-4 level can be done at a fraction of the cost. While they made LLMs more efficient, they also made small language models more capable too. So from an enterprise perspective, where scalability and cost are major factors, do you see small language models becoming a preferred approach in enterprises?
Yeah, that's a great question. And just as I would argue that these innovations have made large models more efficient, the point that you're making, which I think is exactly right, is that it's also making small models more capable. And I would argue that for most enterprise use cases, the small, specialized, highly capable model is really a much better solution. There's a value for some use cases where you want a so-called Ask Me Anything model. For Google or for ChatGPT, you want an Ask Me Anything model. I love Ask Me Anything models. I ask them anything, and I do. But if you're an enterprise, an insurance company, and you're trying to create a chat bot to help people file an insurance claim, you don't need an Ask Me Anything model. You don't even want an Ask Me Anything model. You don't want that model to talk about politics. You don't want that model it doesn't need to know the cast of The Godfather to file insurance claims. So small specialized models are really the way to go when it comes to almost all enterprise use cases. The other advice I oftentimes give people in enterprise is not just think about what you can do with the smaller, more specialized model, but also think about other technologies that can be brought to bear, not necessarily an LLM. That is, the LLM may not be the answer to every problem. In fact, for many problems, you're much better off with some other form of AI, maybe some other form of deep learning, maybe something that's not even deep learning, maybe even something that's not even AI. So you want to pick the right tool for the problem. LLM is not the right tool for every problem, and certainly the large Ask Me Anything LLM is in fact rarely the right tool for an enterprise use case.
I mean, the fact is that enterprises constantly evaluate new technologies. They do look at the new shiny object, but they also have to balance innovation with the stability and reliability. They want AI solutions that solve real problems, not just follow trends. If we remove all the hype from AI, what are the core AI applications where you see enterprises truly rely on AI today? And how is Akamai and its customer leveraging AI beyond the buzzword?
Well, I actually think that we've reached a point where I think you have more difficulty coming up with a use case that couldn't derive some benefit from AI than the other way around. The question then becomes well, what AI and what, if any, role does, say, an LLM play? And I think in many use cases, the LLM does play a role, but it's not the one-stop shop solution. It is a component of a larger solution, a component that can help with the natural language interface, a component that can help summarizing and reformulating the information that's been gathered from maybe other sources. So an LLM can play an important role, but if part of your application needs to be able to recognize images, well, convolutional neural nets are your answer. If you need to be able to reason reliably, well, we have symbolic AI and knowledge representation and a real great corpus of AI around planning and reasoning with symbolic representations of knowledge. That can be a great tool. Or in some cases, maybe you have a component that isn't AI at all. For example, if part of your task involves navigation on a map, well, that's much better accomplished with an actual map than just expecting, say, an LLM to be able to reliably provide navigational information. So you bring all those components together and you bring the right components together with an AI component and maybe an LLM component, and I think you've got a set of tools that can be of benefit to almost any domain. Again, I think you'd have more difficulty coming up with a problem statement where it couldn't get some benefit from AI than the other way around.
Let's just build on top of that. We are also seeing companies like Anthropic embrace hybrid reasoning models. They are combining different AI techniques for better result. What trends are you observing in this space? Do you see that enterprises are moving towards a more blended approach to AI, or they're still relying on one type of model or framework?
Well, I think hybrid reasoning makes some sense. In some domains, you get better answers with one of the multiple techniques, whether it's reinforcement learning or chain of thought prompting or inference search, whatever. You get better results using one of those so-called reasoning techniques than you do without. In other cases, you really don't need all that. Remember, these are expensive. Almost all these techniques require a significant amount of computation at inference time that you don't always need. So a hybrid approach makes sense. Though personally, I think where the term hybrid is actually going to be more relevant is this notion of creating vertically focused solutions out of an ensemble of technology, a hybrid of LLM and other forms of deep learning, a hybrid of LLM and symbolic or neural AI and symbolic AI, a hybrid of AI and non-AI. I think that kind of thinking of bringing together this ensemble, a hybrid of technologies to create a vertically focused solution, that's where enterprises are going to get the real value, and I think that's where we will all see the benefits.
Now, as AI models are becoming more complex and resource intensive, infrastructure plays a critical role in making these technologies more accessible. You folks at Akamai have a very strong history of making technology like Linux, Kubernetes, and cloud computing more accessible. How is Akamai approaching AI in a similar way to help companies deploy AI without facing heavy costs and challenges that come with, scalable infrastructure?
Yeah, well, thank you for the question. I do appreciate that. I always love talking about Akamai. With our cloud offerings, it's very important to us that we address the enterprise use case, which means that there's a really high premium on performance, reliability, and scale. And scale is synonymous with cost. That means you have to be able to do things cost effectively. And what that also means, therefore, is using the right hardware in the right locations for the problem. It's not a one-size-fits-all. And as we see more and more enterprises adopting AI and ideally adopting these smaller models that are more efficient and more capable for the specific problem domain that's being solved, those models run very, very well and much more cost effectively and therefore more scalably on infrastructure that is tuned for that use case, which generally means GPUs that are sort of maybe, for lack of a better term, more in the commodity layer of the various offerings. You don't need a top-of-the-line GPU if you're focused on inference with a highly tuned, specialized model. You also don't want to be running all of that in, say, just one location. You want to have that distributed. You want to be running that near to the entities, users, devices, other AI agents that you're interacting with. So our goal with our cloud offerings, as I said, is to offer that kind of flexibility with cost-effective, highly scalable, high performance, and highly distributed infrastructure. Also, I'd be remiss if I didn't point out that there's a cybersecurity aspect as well. LLMs are notoriously vulnerable. They present an enormously large attack surface, and the protection is paramount. You can't deploy a public-facing LLM, well, probably even an internal LLM as well. You really can't do that without some form of protection. So our cybersecurity offerings are very much focused on protecting all of your application infrastructure and data, and that now includes LLMs and the unique types of attacks that they are susceptible to.
I mean, I'm a huge advocate of open source, and we kind of live in an open source driven world all the way from Linux kernel to Kubernetes. But when we look at AI, like a lot of other technologies, it started as a closed source field. But with the emergence of Deepseek, I mean, Meta is doing some open source work with Llama. But with Deepseek, companies like even OpenAI, they are re-evaluating their approach to open source. When it comes to enterprise customers, does a technology being open source play any role in their adoption, that they lean more towards open source based technologies? And how does Akamai view open source AI for its larger strategy?
One of the areas where I see open source having a big impact actually is on the academic side of things. It's not easy for a university to build its own foundation model. In fact, it's probably cost prohibitive. So most of the research that's being done on LLMs and related approaches requires starting from somebody else's foundation model. And obviously you can't really experiment with a closed source model in as substantial a way as you can with an open source model. So I think that's been one benefit. On the enterprise side, it does mean that as an enterprise, you can now own, if you will, the model that you are using. And that comes with a lot of benefits. It means that you can run it on-prem if you want to, on your own device if you want to, on any cloud if you want to continue to run it in the cloud. It also means that you have maybe more assurance about what that model is doing with the data that you might be feeding it. Because of course, in many enterprise use cases, to get value out of the AI, you need to present it with company proprietary data or customer data. Obviously, that requires protection, and with an open source model, that opens up the possibility of being able to truly inspect the model itself and be confident that it's not going to leak data in a way that would be counter to your interests. So I think that's important. What else? So I think open source has helped in a lot of ways.
And if you just stick to the topic of open source, Deepseek really moved the industry and forced a lot of companies to look at open source AI. Do you see that this is kind of driving to a larger industry shift where open source AI is becoming or will become more dominant, just like Linux kernel and Kubernetes? Or do you think that proprietary models will continue to dominate AI innovation in the long run?
Yeah, one thing I would say is that I do think that the enterprise interest in open source models predates Deepseek, or predates everybody's awareness of Deepseek. I've been talking to customers, enterprises for a long time and talking to them about AI, and I've been hearing enterprise interest in open source models that they could run on-prem on their own devices or in their own cloud or in a public cloud of their choosing. I've been hearing that for probably a couple of years now going back to way before anybody was aware of Deepseek. So I think, yeah, the interest in open source predates people's awareness of Deepseek by quite a bit. Again, I don't, not taking away anything from Deepseek's contribution. I think it's great that they made that choice and that they did as much disclosure on how they built their models as they did.
Bobby, thank you so much for joining me today. Your insights into AI trends, enterprise adoption, and the role of open source is really incredible. I learned a lot from you. There's so much to discuss, and I would love to have you back on the show to continue exploring this topic. But I really appreciate your time today, and I look forward to the next discussion. Thank you.
Very good. And thank you, Swapnil. I really appreciate the questions and the opportunity to speak to your audience about a topic that I love talking about.